Now, a subset of elements chosen from a given set without regard to order is a combination. And that's because a subset is indeed a set and order doesn't matter. As far as sets go, if you have 1, 4, and 6 in a set, that is exactly equal to 6, 1, 4. Those are the same set because order doesn't matter. In a permutation, it's not a set unless you want to think of it as an ordered set. As permutations, these would be two different permutations, but those sets are equal to each other. So these are combinations. Now, the formal definition, although I'm not going to give you a formula just yet, the combination of in things taken R at a time. Combination, capital C, in R. That should look very similar where we had a capital P here that represented the permutation of in things taken R at a time. This is going to be a capital C for combination. It's equal to the number of R-sized, this number R, sized subsets of an in set. Okay, so remember, n is the bigger of the two numbers. I mean, R has to be less than or equal to n. You could not take a subset. If you had a set with 10 elements, there is no subset that has 11 elements in it. So R, the second number, will always be less than or equal to n, equal to the number of R-sized subsets of an in set. Frequently, this right here, frequently the same thing, combination of in things taken R at a time, is read in choose R. It's very common to say that, and it's good because the C can be used as the word choose also. It's like saying you have in elements. How many ways could you choose R of them? And that's exactly what it is. This is just a number this is the symbol that represents that number. So the number of ways that we could choose 3 people from a class of 20. So maybe there's a class that has 20 people in it, and somebody in another classroom broke a bottle or something, and they need 3 people to help clean it up. Well, out of this class of 20, how many ways could you choose 3 people? Well, this is the symbol for it. I'm not telling you what that number is yet. There's a nice simple formula to compute it. But this represents the number of ways out of a group of 20 people that you could choose 3 of them. So you could choose the first 3, the last 3, middle 3, the first one, last one, and middle one, any 3 at all. This is how many ways you could choose 3 people out of a group of 20. So in a combination, elements are always taken from the same set. That makes sense. If we had a classroom of 20 people, you have to choose the 3 people from that classroom of 20. Repetitions are not allowed. You can't choose one person twice. Then you wouldn't have 3 people. You have to choose 3 different people. And the order in which the elements are arranged does not matter. So if I took Ann, Bob, and Charlie, if I said I want Charlie, Bob, and Ann, that means the same thing, exactly the same thing. Order doesn't matter. Okay, so let's write down the formula. I don't think I'm going to write it on this line. The formula for the combination of in things taken R at a time, C in R, is similar to the last time we have a fraction. And remember what the numerator was on top when we had the permutation? It was this number in factorial on top. And then on the bottom, what did we have? We had n minus r factorial. This was the permutation formula. We have to do one more little thing. Just tack on an r factorial on the bottom. You're multiplying 2 factorials together there. That's all it is. So this is a formula you need to memorize. And I think after we do a bunch of examples, you'll probably have it memorized. Now, I'm just going to show you something. Suppose we had something like 10 factorial over 7 factorial times 3 factorial. You cannot multiply factorials together the way you multiply numbers together. In other words, this is not 21 factorial. Absolutely not. This number on top is 10 factorial, which is 10 times 9 all the way down to 1. This number 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And this 3 factorial is 3 times 2 times 1. That 3 factorial is just 6. Okay. Now, if we were going to compare this to the permutation formula, P in R, the permutation of n things, taken R at a time, is just this. This term is missing, the R factorial. Why do you think that is? Well, if you're choosing R people, like let's say we're choosing 3 people from a group of 20, the permutation has to count all the ways you can order those 3 people as well. So the permutation does not. And how many ways can you order these 3 people? If you put 3 people in line for a Coke machine or something like that, you could have 3 people for that one, 2 choices there, and then 1 choice for that. 3 factorial. Well, in the combination, we don't care about how many ways you can arrange the R people that are chosen. So if this is the permutation, and this formula counts the orders, all the possible orders, this is a bigger number than this one, we have to divide out the R factorial, the number of ways you could arrange those R items, because order doesn't matter. So, memorize these 2 formulas. This is the most important one, because I once told you that the permutation formula, I rarely write down this permutation formula. I simply think of this as being the first R terms of n factorial. Remember that? For example, let me do 4, 2. It's just the first 2 terms of 4 factorial. I leave off the 2 times 1. It's much easier for me to remember that than the formula, but you have to remember, you have to memorize this formula. Well, let's practice a couple simple examples. And before I compute this, let's say what this is. It's the combination of 10 things taken 8 at a time. So maybe you have a room full of 10 people, and somebody comes in and says, hey, can I borrow 8 people? I need a little bit of work done for a couple of minutes, and I need 8 of you. So how many ways could you choose the 8 people out of this group of 10? Let's use the formula. This is the N, and this is the R. The second one is the R. So the 10 factorial goes on top. And what do we get on the bottom? Well, it'd be 10 minus 8 factorial. 10 minus 8 is in parentheses, so that's really a 2 factorial, times the n factorial, 8 factorial. So if I were to write this again, it'd be 10 factorial over 10 minus 8 is 2 factorial, 8 factorial. All right, I'm going to go ahead and simplify this. Remember what 2 factorial is? It's 2 times 1. It's just 2. 2 factorial is just 2. And what is 10 factorial over 8 factorial? I usually take the larger of the 2 numbers on the bottom and cancel it out with the 10 factorial on top. So maybe I'll do it like this. 10, 9 times 8 factorial over 2 times 8 factorial. So all I did there is on the bottom I made 2 factorial equal to 2, so I simplified it. I didn't need the factorial. 8 factorial is 8 factorial, but on top I wrote 10 factorial, which is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 all multiplied together. I wrote that as 10 times 9 times 8 factorial, which goes from 8, 7, 6, 5, 4, 3, 2, 1 multiplied together. And now I'm able to cancel those. So this is equal to, let's see, 10 times 9 is 90, over 2 would be 45. So this is equal to the number 45. The number of ways you can take a group of 10 people and choose 8 of them. There are 45 different ways you could choose the 8 people. And just remember, a group is only the same if it's exactly the same. So if you took one group and then just switched out one other person, that gives you a brand new group. Every little change, if it's not exactly the same people, it's a different group. All right, the combination of 7 things taken 3 at a time. Remember what goes on top? The number on the left. That's the 7 factorial. And then in parentheses, I would say 7 minus 3 factorial. I'm just going to write it like 4 factorial, and then 3 factorial. One thing you'll notice is the 2 numbers on the bottom that you're taking the factorials of always add up to 7. And why is that? Before I simplify this, let's show why that is. Here we have n on top that we're taking the factorial of. What are the 2 numbers on the bottom we're taking factorials of? N minus r and r. What do you get when you add n minus r and then to r? Well, the negative r and the positive r cancel out and they give you n. So this is equal to, I'm going to go a little bit to the right, 7 times 6 times 5 times 4 factorial. And why did I do that? Because 4 factorial is the bigger number. I could have gone all the way down to 3, 4 times 3 factorial and canceled this, but I like to cancel the bigger of the 2 numbers on the bottom. So let me reorder them now. Let me write 6 times 4 factorial. Where did that come from? Well, the 4 factorial, I switched the order of the 2, so that's the 4 factorial. What is 3 factorial? What's 3, 2, 1 multiplied together? 3 times 2 times 1. It's 6. So now I'm going to cancel those 4 factorials, and look at this. I can cancel the 6's as well, and what does it leave me with? 7 times 5, 35. So if you had 7 people in a room, and let's say, let's see, if you've ever played cutthroat racquetball, it takes 3 people to play. It's like a 1-on-1-on-1, 3 people playing on the same racquetball court. If you had 7 people in a group and you could only play 1 game of cutthroat racquetball, you only had enough time, say, for 1 game, it takes 3 people. How would you choose the 3 people out of the 7? Well, I don't know how you would choose them, but there are 35 different ways that the 3 people could be chosen from that group of 7. All right, one more. 12, we could read this as the combination of 12 things taken 2 at a time. How many ways could you choose 2 people out of a group of 12? And remember, we also call this 12 choose 2. How many ways can you choose 2 people out of a group of 12? Well, the 12 factorial goes on top. And what goes on the bottom? What 2 factorials? Well, you know one of them is going to be the 2 factorial. Actually, you could write that down. And then the other one is going to be the number you'd have to add to 2 to get 12. 10 factorial. Simple as that. And that really, by the formula, the 10 comes from 12 minus 2. That gets you the 10 factorial, and then just put this number 2 factorial down there. So this, if the 2 factorial were not there, I wonder if you could tell me what that's equal to. 12 factorial over 10 factorial. Hopefully you're starting to get used to this. It's just 12 times 11, because 12 factorial is 12 times 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All those numbers multiplied together, and in the denominator you have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So the 10 factorial cancels from 10 down to 1, and it leaves you with 12 times 11 on top. And then we've got 2 factorial on the bottom, which is just 2. So now we can cancel the 12 and the 2, leaving me, what, a 6 on top. And that would give me 6 times 11 for 66. So suppose you have one checkerboard in a group, you got 12 people in a room and one checkerboard, and there's only enough time for one game to be played. How many ways could you choose the 2 people to play that game? 66 different ways.